Once the changes,
What is calcium doing?
what's what?
Calcium doing. So it took the one sodium and potassium.
Hold on to that thought, because we're going to get to the calcium. Yeah. All right, so now we're at the point where things have taken place along that plasma membrane. But the structure of a muscle fiber, of a muscle, okay? I had that part that I mentioned was invaginating through. I've got my sarcoplasmic reticulum, these little terminal cisterns, okay? This structure is going to get affected, okay? So in looking at the structure, if we get the action potential, and if we begin to have the charges change across that plasma membrane, we're going to see that we're going to have the sarcolemma involved, those T-tubules, the little things that are invaginating down in between. We're going to have the little cisternae, the little webby looking stuff. We're going to have the reticulum. Now, we get what's formed, a triad, when we have one of the T-tubules, okay? So if this is a T-tubule, and these areas, these little webby things on each side, okay, the two webby things and the T-tubule together, that's three things. So it forms a triad, okay? So we've got a triad when we have this little T-tube and the webby things, the cisternae, okay? So the triad is going to be present. Calcium. Wait a minute. Where is that going to be in my structure here? Ooh, the plot thickens. And then we've got our troponin. The troponin was that little 3-unit thing that sat in the little indent of the tropomyosin. Huh? What? Huh? What? All right. Y'all ready? Okay. We know that we're looking at the working of the sarcomere. All of this structure that's taking place, where we've got the T-tubule, the webs, okay? If I have my neuromuscular junction, stuff is going to start to spread, okay, along that fiber. Now, that invagination, the T-tubule, look what gets to happen. My action potential got started, and it now passes down the fiber. But what does it also pass down? The T-tubule. And the T-tubule is in connection to the sarcoplasmic reticulum, that webby looking stuff, okay? What do we see being held in the sarcoplasmic reticulum? Huh? What? Huh? Oh, calcium. So, this webby stuff is storing calcium. And there's a reason for that. So the calcium, with that action potential, passes down the fiber and passes down the T-tubule to affect the cisternae, the reticulum, all right, what do we see happening to calcium? It gets let go. So that reticulum, that cisternae, okay, releases calcium. Now, that T-tubule is like another boundary for a sarcomere. So in that sarcomere, from Z disc to Z disc, okay, I've got my thick and my thin filaments. So the calcium gets released, and what do you see this picture trying to show the calcium doing? We're seeing it move towards this thick and thin filament makeup. So if we break that up, okay, if we blow it up, my thin filament, my thick filament, my troponin, the tropomyosin. Now, at rest, the tropomyosin, the rope, is covering the binding sites. But at every single indentation, I've got the troponin. Now, when the calcium gets released, the calcium will bind to the troponin. And because the troponin is hooked to the tropomyosin, it's going to make the troponin shift, and when it shifts, it pulls the tropomyosin. And now, what becomes available? An active site. So when that action potential moves down, passes into that T-tubule, affects that sarcoplasmic reticulum, calcium gets released, calcium will go and bind to the troponin. The binding between the calcium and the troponin makes that whole tropomyosin rope shift. And now all of those active sites on that thin filament, all of those active sites are now available. If they are available, what can attach to them? The myosin head. So now, this myosin head, now granted, it's got to have energy, okay? We've got to have the ATP. But that myosin head gets to and stick into one of those active sites, okay? And then it does this number, and it'll release. Go back up, attach to another one, and continue to pull. So all of those myosin heads are active doing that if the ATP is present. So if you've got all these myosin heads moving into a binding site and then pulling that thin filament, they are sliding the thin filament across them. And they're sliding it towards the midline, the middle of the sarcomere. What you think of the calcium now here?
Like, it makes our essay question, like, I don't know, I can like see it better.
Therefore, giving you some idea of the importance of calcium in the body. We've still got the sodium, we've still got the potassium, we've still got the sodium-potassium pump, okay? And now we've got to have the calcium. Yes, no, maybe. Take a break, be back at 12:30.